So, hello everyone. Today, I will be presenting my project on 4-bit arithmetic logical unit for ALU. Unit using ESP32 line. This project uses text which is binary numbers to display the calculation results. The ALU performs basic arithmetic operations like addition and subtraction, demonstrating how co-computing arithmetic is done at hardware level. So, what ALU? ALU is a critical component in a computer's CPU responsible for carrying out arithmetic and logical operations. A 4-bit ALU processes numbers represented in 4 binary bits, which means we can represent values ranging from 0 to 15 in an unsigned system. Using a method called whose complement, we can also represent negative numbers from -8 to +7. ALU takes two such 4-bit inputs and produces a 4-bit output that is displayed by LEDs. So in this 4-bit system, each number has 4 bits, each either 0 or 1, allowing 16 unique binary combinations. For representing negative numbers, the most significant bit acts as a sign bit in whose complement format. Our ALU performs basic addition and subtraction. Subtraction is done by adding the 2's complement of the second number. While this project focuses on these two operations, typically ALUs also support functions like AND, OR, and SOLVE. Now, hardware components and setups. The key hardware component used are easily developable with multiple GPI pins, two sets of 4-bit tip switches for input A and B, input to select the operations, and 5 LEDs to indicate the results. 4 LEDs for results bit and 1 for the sound. Current limit resistors ensure the protection for the LEDs of crystal and jump wire wires connect the components to the microcontrollers on the board. Now the pin configuration as it is shown here, we have input A as per as per our first tip switch using GPIO pins 32, 33, 24, 26. Input B using 27, 14, 20, 12, and 13. Add switch using 15, subtraction switch using 4. Result LEDs using 3, 5, 18, and 19. And sign LED using GPIO 23. This is how our program to present all the IVs are simple, simple using physical components. Right now. Now, the working instrument is that ESP32 means the state of the bits which is through its GPIO pins. Low signal corresponds to energetic signal. Takes which arithmetic operation is selected by a dedicated operation switch is command control with the structure using arithmetic operations and base in the flow simulation. Outputs the binary result of readings with a separate relation in the same. Additionally, additional rules are sent with serial monitor for delay. Operation demonstration is that suppose we are taking input as A as 5, and B input as 3, and the add switch is selected. That means the ALU computes 5 plus 8, represented as 0.000, and LED with the 7 LED data as positive. For subtraction, we put the same inputs and substitutes until the result is 2, position, and the LED is positive information. The visual output helps verify operations of the ALU. A software logic breakdown can be experienced. The ESP32 formula reads tip switch positions to G2 independence using digital code. Input pull-up resistors. Architects. operation select executes addition or subtraction. Bitwise operations extract each bit of the result, which is then encoded with corresponding LEDs using digital controllers. Serial output on the computer helps with data. Now, results in real time. ESP32 also sends operation to the serial monitor for real time. The serial monitor is an interface where the microcontroller and your host PC can communicate with each other using a specific baud rate. The baud rate which I used was 9600. Baud rate depends purely on your load and what you set for your content. Now, the serial monitor is implemented so that in case the hardware is faulty, you can actually look for debugging in also. There are logic is random. This helps us reduce one step of debugging. That is why we use serial output. For real world applications may include educational foundation for very huge children, complicated topics like signal processing, and the basics of electronics using this. You can embark on children basic immune system design using this kind of service. You can also do logic circuit experimentation. Practical implementations in how actually CPUs perform basic operations. We can use it for prototyping and testing high-level circuits as well. In conclusion, this project successfully implements a 4-bit rule using an ALU which inputs one input switches and outputs other images, demonstrating binary arithmetic fundamentals respectively, which are enhancements could include anti-money on arithmetic and logical operations overflow handling on floating user design, other microcontrollers, FPGA platforms, and foundations of advanced virtual systems.